Hello students, welcome back to my YouTube channel Chemistry and Biology Concepts. HSTR 2022 Chemistry class first. Acid, bases and salts. So coming to the acids, bases and salt. Here the chemical compounds, about the introduction we have to discuss first. Chemical compounds are naturally occurring and are essential for life. Chemical compounds are broadly classified into three main types. They are acids, bases and the salt. Example for this acid is tartaric acid, citric acid, hydrochloric acid, etc. Bases are sodium hydroxide, calcium hydroxide, potassium hydroxide. Salts example sodium chloride, sodium carbonate, silver nitrate. Coming to the first category, that is acids. So acid meaning means the word acid comes from the Latin word that is acidus, which means sour. There are two types of acids will be present. That acids can be classified into two groups. They are organic acids, nothing but carbonic acid, and mineral acids are acarbonic acid or inorganic acid. So coming to the first type, that is organic acid or carbonic acid. These are the acids can be occur in nature is called as organic acid. Example for that organic acid is tartaric acid, acetic acid, formic acid. Next coming to the second one, that one is mineral acid or inorganic acid or acarbonic acid. Mineral acids are made or prepared from minerals present in the earth. From the earth, minerals will be there, no? In that, they are using the minerals for preparing these mineral acid. Example for that is hydroxides of sodium, potassium and copper. Nothing but sodium hydroxide, potassium hydroxide and copper hydroxide. So coming to the examples for organic acids. These are occurring in the nature, no? So here are some examples of acid and where it will be occurring that I have listed below. Citric acid and ascorbic acid, you can get these kind of acids in a lemon, orange, etc. Tartaric acid. Tartaric acid will be present in the tamarind, unripened mango, grapes, etc. Lactic acid will be present in the milk curd. Oxalic acid will be present in the spinach, tomato. Folic acid will be present in the turnip, broccoli, peanuts and sunflower seeds. And sixth one is acetic acid. It is obtained from the vinegar. Formic acid. It is present in the ant. So this is about the examples for organic acid. So coming to the properties of a acid. First, the properties of acid are classified into two types, that is physical properties of acid and chemical properties of acid. Coming to the physical properties of acid. First property is taste. Acids are sour in taste. Conductivity. How the acids will be conduct electricity, that they have given here. A few drops of an acid in a water makes water a good conductor of electricity. Next, stability. Acids are soluble in water. Acids should be added to water drop by drop with constant stirring. The beaker containing this solution become hot as it is a exothermic reaction. Corrosiveness. Fourth property of a physical property of this acid is corrosiveness. Acids are not stored in metal container because acids corrodes the metal like iron and aluminum. Hence it is safe to store in a glass container. This is the physical property of a acid. So coming to the chemical properties of a acid. So first reaction with the acid with the metals. When acid react with a metal, it forms salt and hydrogen gas. Here I have given one example for that. Metal I have taken as a magnesium and acid HCl I have taken. So magnesium reacts with the HCl to form MgCl2, magnesium chloride, plus hydrogen gas will be going to be liberate. So when the acid reacts with a metal, it forms salt and hydrogen gas. Reaction of acid with the carbonates and bicarbonates, what happens? Here you can observe here. First example I have taken calcium carbonates react with the HCl, nothing but hydrochloric acid. It forms calcium chloride plus water plus carbon dioxide. Like that only sodium, here I have taken sodium bicarbonate, for the reaction of acid with the bicarbonates, I have taken sodium bicarbonate. When sodium bicarbonate react with the hydrochloric acid, NaCl, nothing but the salt. NaCl, CaCl2, even these are all the salt. Salt along with the water and carbon dioxide will going to be produced. So this is about the chemical properties of a acid. After this, what we have to learn is about the uses of acids. In that first acid use we have to learn is hydrochloric acid. Hydrochloric acid is used in the manufacture of glue and purifying common salt. It is in the preparation of glucose and chlorides, for bleaching in textile industries, and also for the cleaning metals before they are tinned or soldered or galvanized. Here galvanization, important concept I have given here. Galvanization is a process of coating iron or a steel with a zinc, either by immersing in a bath of a molten zinc or by deposition from a solution of zinc sulfate. This is done to avoid the corrosion. To avoid the corrosion of a metal, we are going to do the galvanization, that is depositing of a zinc on the other metals to stop the or avoid the corrosion. So this is about the uses of acid in that hydrochloric acid. Second acid is nitric acid, HNO3. To etch designs or names on metals like copper, brass and bronze, these nitric acid will going to be used. It is used in the extraction of metals from their ores. Here I have given the ore definition. You can see here. It is naturally occurring mineral that yields metal or a valuable minerals. So in the purification of precious metals like gold and silver. So gold and silver, purifying these precious metal, they are going to use nitric acid. Even in the manufacture of some dyes. Dyes means coloring compound. Perfumes, you have already know that. Plastics, rayon is a artificial silk. These rayons are obtained from the fruit pulp. And this one is a fertilizer. Fertilizer example TNT they have given, trinitrotoluene and nitroglycerin, and these are used in the medicines also. These nitric acid is used in the medicines. Or I have already explained. And next, third one is aqua regia. In etching designs on metals like gold and platinum. Aqua regia means what I have given here separately. So it is a mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. So if they will give what is the ratio of aqua regia, you have to write hydrochloric acid and concentrated nitric acid. Hydrochloric acid is in 3 and nitric acid you have to write it as a 1. So 3:1. If they will give this one reversely, that means nitric acid and hydrochloric acid, if they will give means you have to write 1:3. So if they have given concentrated hydrochloric acid first and then nitric acid means 3:1. This mixture dissolves noble metals like gold and platinum. So this is about the aqua regia. So coming to the fourth acid, that is sulfuric acid. So this sulfuric acid is a H2SO4. Sulfuric acid is commonly called as king of acids because the manufacturing of sulfuric acid used in the so many uses you are going to get from the sulfuric acid. So here 3 to 4 uses I have given here. To refine petrol, and also in the manufacture of fertilizers, example ammonium sulfate, superphosphate, detergents, drugs, plastics, paint and chemicals like copper sulfate, Epsom salt. Now, by the preparation of all these things, only the sulfuric acid is used for these things. In paper, leather, textile and automobile industry also H2SO4 is going to be used. Here Epsom salt you have learnt, no? This Epsom salt means the Epsom salt is a magnesium sulfate, MgSO4 7H2O. It is naturally occurring mineral in water. So Epsom salt is a naturally occurring mineral in the water. The chemical formula for this Epsom salt is magnesium sulfate 7H2O. H2O nothing but water. Its name is derived from the town of Epsom that is there in the England where the compound was first distilled. So this Epsom salt was first distilled in the England, in the town called Epsom. That's why the name of this salt is Epsom salt. Remember this one, very important for HSTR. So fifth one acid is carbonic acid, H2CO3. It is also used in the aerated soft drinks. Whatever the soft drinks you are going to drink now, in that preparation they are going to use carbonic acid, HCl. Depending upon the concentration of hydrogen ions, the acids are classified into two main types, that is strong acid and the weak acid. First one, strong acid. It is an acid which completely ionized in an aqueous solution. Example I have given here, HCl, hydrochloric acid, ionizes completely into the hydrogen and chloride ions in the water. Yes. Example for strong acids are HCl, hydrochloric acid, H2SO4, sulfuric acid, HBr, hydrobromic acid, HNO3, nitric acid. This is the example for strong acid. Weak acid. Coming to the weak acid, it is an acid which partially dissociate into its ion in an aqueous solution or water. Example for that is acetic acid, CH3COOH, H2C2O2, that is oxalic acid. So coming to the today's concept, that is about the base. The word base came into use in the year 1771 by a French chemist Louis Lumiere. Louis Lumiere. The word derived from a Latin word bases, which means low. The oxides and hydroxides of metals are also bases. See here, the bases are the substance that can accept hydrogen ion in water and can neutralize an acid. This is the definition of the bases. Bases dissolves in water, they split up into the metal part and the hydroxyl group are called alkalis. For example, NaOH dissociate into Na++OH minus ions. Example, sodium hydroxide, calcium hydroxide. All alkalis are base, but all bases are not alkali. Here you have doubt about the alkalis. Here I have given the definition and example for that alkalis. The base that dissolve in water are called alkalis. Example for that is sodium hydroxide, potassium hydroxide. The base which do not dissolve in water are called non-alkalis. Example is aluminium hydroxide and copper hydroxide. Here comes the types of base. There are mainly 5 types of bases, that is weak base, strong base, super base, neutral base and a solid base. Coming to the weak base, there is a incomplete dissociation when in water. This base is weak when it dissociate incompletely in the water. Example for that is ammonia, NH3. Strong base, it is a compound that complete dissociate into its ion in water. Example is KOH, potassium hydroxide, NaOH, sodium hydroxide. Third type is super base. The bases are better at deprotonation when compared to a strong acid. Example is sodium hydride, NaH. Neutral base, it is form a bond with a neutral acid, share an electron pair. Example for that neutral base is Na2CO3, sodium carbonate, NaHCO3, sodium bicarbonate. Solid base, last fifth type of base is a solid base. It is active in a solid form. Example for that is silicon dioxide, sodium hydroxide mounted on alumina. Coming to the physical properties of a bases. First property is taste. Bases are bitter in taste. Example for this is a bitter gourd. Feel. How you are going to feel when you touch the base means soapy. Conductivity. Solutions of bases are very good conductor of heat, very good conductor of electricity. Corrosiveness means some bases are corrosive in nature. Example I have given here, sodium hydroxide. Sodium hydroxide is the most corrosive base. For HSTR they are going to ask which is the more corrosive base. So what you have to write is sodium hydroxide, NaOH, and H2CO3, carbonic acid. H2CO3 is a chemical formula of carbonic acid. So carbonic acid is the least corrosive acid. So coming to the chemical properties of a base, first property is bases react with the acid. When base react with the acid, it forms a salt and water. Example, calcium hydroxide reacts with the H2SO4 sulfuric acid, give rise to calcium sulfate, that is salt, plus water. Second property are bases lose their basicity when mixed with the acid because these bases are neutralizes the acid. Base change the color of a litmus from red to blue. Uses of a base. So here comes the uses in that first one, sodium hydroxide NaOH, commonly called as caustic soda. Soda. In textiles, these sodium hydroxides are used in textiles, plastic and soap industries, and also to refine the petroleum, and used in the manufacture of rayon, medicine and paper. So this is the uses of sodium hydroxide. It is one of the base. Calcium hydroxide is commonly called as slaked lime, CaOH twice. It is used in whitewashing and also in the antidote for acid poisoning. It is used in the manufacture of bleaching powder, cement, mortar and fungicides, and also removing fur from animal skin. They are going to use calcium hydroxide, nothing but slaked lime. Coming third one is ammonium hydroxide, NH4OH. To remove ink from cloths and grease stains in the manufacture of fertilizers like ammonium nitrates, dyes, plastics and nylons, these ammonium hydroxide is going to be used. See, ammonium hydroxide is the only base that does not have a metal atom in it. Instead of it, it has a NH4 plus radical in it. Coming to the neutralization, when acid react with the base in a quantitatively to form salt and water as a product. Uses of neutralization means bee sting or acidic. Example for these neutralizations are bee sting are acidic in nature for that purpose and applying a baking powder, that is sodium carbonate, that neutralizes the acid that contain in the bee sting. Another one example uses neutralization is farmers mix lime, that is calcium oxide to the soil which is acidic to neutralize the soil to make it to fit to grow plants. Farmers use calcium oxide to neutralizes the soil that will fit for growing plants in it. Salts can be formed by the reaction of acid with a base. When acid reacts with the base, it forms a salt. Coming to the properties of a salt, most of the salts are solid with high melting and boiling point. Most salts are soluble in water and make the solution good conductor of electricity. Coming to the example of salts, KNO3, that is potassium nitrate, and NaCl, sodium chloride. So, coming to the uses of salt. Sodium chloride, commonly called as common salt, required small quantity by the human body and add taste to our food. Very essential in pickling and currying of fish and meat. Necessary in the manufacturing of chlorine, hydrochloric acid, sodium carbonate, sodium hydroxide and sodium bicarbonate. Sodium carbonate, Na2CO3, commonly called as washing soda. It is used in the to wash cloths, to refine petroleum, and used in the manufacture of caustic soda, borax, detergents, papers and the glass. Yes, coming to the sodium bicarbonate, NaHCO3, commonly called as baking soda. It is used in the bakery products like bread and cake, used as an antacids and also used in the fire extinguishers. Coming to the fourth one, copper sulfate. So, copper sulfate chemical formula CuSO4, commonly called as blue vitriol. It is used in the manufacture of medicines and used as a fungicides and for electroplating, making dyes and in calico printing. Coming to the fifth salt, that is potassium nitrate, KNO3. It is used in glass, preparation of glass, fertilizers and refrigeration industries. Manufacture of gunpowder, they are going to use potassium nitrate. Coming to the sixth one, that is potash alum, KaISO4. Potash alum is used in the purification of water and in the tanning industries. Coming to the seventh salt, that is silver nitrate, AgNO3. It is used in the developing films. Today it is not in much use as we have digital photography. So this is about the uses of salts. Coming to the indicator. Indicators are the chemical substances to indicate if a substance is acidic, basic or neutral in nature. There are mainly two types of indicator, that is natural indicator and the artificial indicator. Coming to the natural indicator that can be found naturally. Most commonly used indicator is litmus paper, that is I have showed in the picture. So turmeric, scientific name of turmeric is curcuma longa, and red cabbage are natural indicator. The natural indicator that is litmus is obtained by the lichens occur in blue and red color litmus. So in the below picture I have showed the natural indicator images. In that China rose you have seen, no, that one is commonly called as hibiscus. Scientific name is Hibiscus rosa sinensis. So coming to the artificial indicator, those indicators that are obtained through some chemical reactions but not naturally are prepared artificially in the laboratory. The other indicator used in the laboratory are methyl orange or methyl red and phenolphthalein. So I have showed the picture here, phenolphthalein that is colorless and methyl orange or methyl red that is orange in color. So coming to the pH value, it is possible to measure the acidity or basicity of a strength of a substance. It is measured using a special scale called a pH scale. pH is the measure of concentration of hydrogen ion and it indicates the acidity or basicity or alkalinity of a solution. If the value of a scale is 0 to less than 7, then it is called as the substance is acidic in solution, acidic in nature. That is from 0, 1, 2, 3, 4, 5 up to 6. From 0 to 6 it is acidic solution. If the value of the pH scale is more than 7 up to 14, that is 8 to 14, the substance is called as basic and the 7 is the neutral. So coming to the importance of pH in our daily life. Here I have showed the picture, and in our daily life whatever the substance we are using that is having a particular pH. Here I have given the one picture of about the pH scale. You can observe here. Yes, that is alkaline ionized water, lettuce, spinach, radish, banana, apple, cabbage, carrot, eggplant, potato, cucumber, onion, bean curd, milk, healthy body. These having a pH above 7 up to 14, hence it is comes under the alkaline substances. So 7, pH 7 having a bread, cheese and beer, it is neutral substances. From 7, 6, 5, 4, 3, 2, 1 up to these are acidic in nature. So it is having some substances in we are using in our daily life, that is octopus, beef, sugar, pork, eel, raw salmon, chicken, whiskey, rio, paracetamol, rice wine, clavier, egg yolk. These are all comes under the pH below 7, that is acidic in nature. This is the importance of a pH in our daily life. So I hope you guys understood the concept very well. So this is about acid, base and salt. In the next class we will discuss about another interesting topic about the HSTR concept. So make sure that you subscribe to my channel. Please like, comment, share and subscribe. Thank you for watching.